Okay, so in this problem, we're told a material point is observed to start yielding at the state of plane stress represented in the figure. So we're talking about this figure right here, and we're told to determine the uniaxial yield limit, sigma yp. And we're going to be doing this according to two different yield criterion. So we're going to be doing it to the Tresca and von Mises. So that's what we're going to be doing for this problem. And so the first thing we need to do is recognize what they're asking us for. So we're trying to find sigma yp based on two different theories. So the first one is Tresca and the second one is von Mises. So the first thing I'm going to show you guys is the formula for both of them. So let's go ahead and start off with von Mises. So the formula for it is sigma 1 minus sigma 2. Let me do it like this, von Mises. So sigma 1 minus sigma 2 squared plus sigma 1 minus sigma 3 squared plus sigma 2 minus sigma 3 squared. And so this has to be less than or equal to 2 multiplied by sigma yp squared. So this is the formula for von Mises. So notice we're trying to solve for this sigma yp value right here. And so basically what this is saying is that the principal stresses here, right, sigma 1, 2, and 3, when you put them in this formula, they have to be less than or equal to this sigma yp, which is where it will right, break or yield, right? So what we're trying to find is this value such that it like is equal to this, because that's the point at which it will right, it'll break, or where it'll yield, right? So this is the formula for von Mises, and then we're also going to want to do it for Tresca. So let me write that out. So for Tresca, the formula is a little bit easier. It is going to be equal to sigma max minus sigma min. You're going to take the absolute value of that divided by 2, and that's going to be less than or equal to sigma yp over 2. So all we're doing is using these two formulas and solving for sigma yp. So that's what we're going to be doing. But obviously, you should notice we're going to need the sigma 1, or the principal stresses. And so these just represent the principal stresses, but just the max and the min. Yeah, so based on this figure here, we're going to have to solve for those values. So let's go ahead and do that. So the way we solve for the principal stresses, notice this is a 2D element. So sigma 1 and sigma 2, the formula for it is sigma average plus or minus r. So sigma 1 would be plus r, sigma 2 would be minus r. So starting off with sigma average, the formula for it is sigma x plus sigma y over 2. And so now what we need to find is sigma x and sigma y and sigma z. So let's go ahead and do that. So let me just write this out here. So let's look at our diagram. So we have to find sigma x, sigma y, and I know I said sigma z earlier. I actually meant the shear. Let me just write it out like this. So we have our shear stress, we have our right, x and y sigma stress. So let's go ahead and solve for that. So based on this diagram, we have to figure out these values so we can plug them in over here. So what you want to do is basically look at these three values. So starting off with sigma x, we're basically talking about the value along here, parallel to the x direction, which I didn't label it, but that's the x, and this is the y. So notice that the 10 is parallel, so that's going to be our sigma x, and then it's positive or negative depending on whether it's pointing in or out. So the 10 is pointing inwards, therefore it's negative. If it was out, it would be positive. So minus 10 MPa is our stress in the x. And then in the y, we have, right, so you look at parallel, right? So for the y, the 2 is parallel, and it's going in again, so it's negative. If it was going up, it would be positive. And then for the shear, notice that what you want to look at is this value. So this value is going to be this shear, the one in like the corner, I guess. And depending on where the arrows point is whether it's positive or negative. So if they're both pointing down like this, the value is negative. If they point like this, then it's positive. So in this case, since both are the arrows here, right, they're pointing to this corner and this corner, it's negative. And if it was the opposite, this corner and this corner, it would be positive. So we know the answer is going to be negative, so -3. So now that we have the stress in the x, y, and our shear stress, we can just go ahead and plug it in. So plugging that value in, sigma x plus sigma y, that's -10 plus -12, or sorry, -2. So this is just -12 over 2, which equals -6. And then we're talking about stress here, so it's still an MPa. So now we have the sigma average, which is our first thing we need. And then we need R. So the formula for R, right, which is the radius of our Morse circle, is the formula for it is right here. So let me go ahead and write that out. Yeah, so this is the formula for R, which we just need now. So R is equal to the square root of sigma x, which was -10, minus sigma y was -2, and then the shear is -3. Plugging this in, so -10 minus -2, that is -8, and then you're dividing by 2, so this is equal to -8 over 2 is -4. So -4 squared is 16, and then 3 squared is 9. So you have the square root of 25, which this value is just 5. You should just know that. So 5 is your R value. So going back up here, our sigma 1 and sigma 2 is sigma average minus 6 plus or minus 5. So your values, if we add 5, it's going to be -1. If we subtract 5, it's going to be -6 minus 5, which is -11. So sigma 1 and sigma 2, these are your two values. And then the third, sigma 3, because, right, for these formulas, you need 3 values. Since we're only dealing 2D, your sigma 3 is just 0. So your third principal stress is 0. So your values are -1, -11, and 0. And then obviously these are MPa. So these are your 3 principal stresses. And then, yeah, now that we have these, it's just a matter of plugging them in. I'm going to start off with the von Mises. So just plugging in the value. So sigma 1 we said was -1. So -1 minus sigma 2, which is -11 squared, plus sigma 1, which is -1, minus sigma 3, which is 0 squared, plus sigma 2, which is -11, minus sigma 3, which is 0 squared, is less than or equal to 2 sigma yp squared. So -1 minus -11, so you're just adding 11 to -1, it's going to give you 10, so 10 squared, plus -1 minus 0 is still -1, so -1 squared, plus, and then -11, still -0 is still -11 squared. Cool, so you have 100, plus this is going to be 1, and then 11 squared is 121. The negatives obviously just cancel out. So this is what we got. And then 100 plus 1 is 101, plus that's going to be 222. Yeah, 222. Yeah, and then you're just going to want to divide by 2. So this divided by 2 is 111. It's less than or equal to sigma yp squared. And then you would just square root both sides to get rid of the square. So the square root of 111, you should know, or you plug it in your calculator, sorry, is 10.54. So sigma yp, right, is equal to 10.54. So this is when it would yield, right, So let me go like this. So MPA. And yeah, so that's going to be your answer to, right, the von Mises. So that was the second one. Yeah, and then now for the Tresca, it's just once again plugging it into the formula. So this one, we don't have sigma 1 and 2 and 3. We have the max and the min. So what you want to do is just look at your value. So the max value here is 0, and the minimum value is minus 11. So those are going to be the values we choose. So you have max minus the min divided by 2. So 0 minus 11 over 2. Yeah, and that's less than or equal to sigma yp over 2. So 0 minus 11 is minus 11. But obviously you're taking the absolute value. So you really just have 11 over 2 sigma yp over 2. Your 2's are just going to cancel. So the value is going to be equal to 11 MPA. Let me make sure I wrote that here. Yeah, MPA. So basically you're just going to get two different values since we're using different criteria, and those are just for estimating when it's going to yield. So yeah, these are going to be your answers. Keep in mind this is for Tresca, and then this one was for the von Mises. But yeah, it's really just plugging it into the formula and then being able to solve for your principal stresses. But yeah, so this is going to go ahead and be your answer to the von Mises, and this is your answer to the Tresca. Sorry about my handwriting. But yeah, so these are going to go ahead and be your answers, and hopefully you found this video useful. Hey everyone, I just wanted to say thank you for watching the video, and if you're interested in helping to support the channel and some other interesting perks, please consider becoming a channel member today. You can find more information on that by clicking the join button, which is located next to the subscribe button. And then also, if you're interested in one-on-one private tutoring from me, whether that's in engineering, physics, or math, please check the description for more information on that. But yeah, thank you and happy learning.